Make sure the microphone is working. Looks like it's working. So welcome. Big day, final demo. Excited? Maybe a little bit, there's a lot of excitement, but you can't hear it. So we're going to get started with our final demos for Capstone projects in computer science. This is my 4398 section 2. We are going to start with, we're going to have 3 projects today. First up will be Optimap, second will be Tradester, and then our third will be TuTraffic. So I'll give us all a minute to move, but Optimap, you have the floor.
Yeah, you guys, we don't have an accumulate. You got time. And I can stay muted, right? Because the mic is.
Yep, mic is
all good there.
live.
All right.
Okay.
You good? Yeah. All right, so my name's Ben. This is Alex, and that's our Optimap team back there. But we're going to be doing the demo today. So Optimap is a progressive web application, which means you can view it on mobile as well as desktop. But ours is primarily for mobile, and it's basically an app that allows people to plan trips based on certain things like locations and times that you need to get to the certain locations, as well as some cool other features such as social features. So with that being said, we're going to go ahead and get into our demo. So, like I said, my name is Ben, and for this demo, I'm in the Philadelphia area and I want to visit some colleges. So I heard of this cool app called Optimap that can help me with that. So I'm going to go ahead and open this. And right away, first, what I'm going to do is just go ahead and create an account. So make an email, say Ben10 because it rhymes. And I also haven't used that email before. Make my password. And go ahead and sign up, and then it automatically logs me in. And as you can see now, there's more options on the nav bar. So like I said, I kind of want to get a feel for the area. So I'm going to allow my location here. And I can kind of see where I'm at on the map, which is cool. And I also have some locations in mind that I want to add really quick just to see where they're at. So I've heard Temple's a pretty good school, so I'm going to add that. I've also heard Villanova's a school in the area, and I've also heard of Drexel. So I'm going to go ahead and add those and look at my locations list, but that's kind of interesting. I didn't know that Villanova was that far out, and it actually ended up putting it third despite me adding it second, which is kind of cool. So I wouldn't have known to go there last, but it looks like now it has me going to Temple and then Drexel and then Villanova. So that's pretty cool. And if the map's too overwhelming, I can actually click here and look at the directions turn by turn if I want to get familiar with the streets a little bit. So that's cool. But I think I have I'm pretty familiar with the area now. So I'm going to go ahead and actually create a route in a more organized manner. So I have some places that I need to visit. Like I said, Temple, but that's a open house. No need to put the time there. I'm also going to head to Drexel. They're having something going on at 9:30 in the morning. So I'm going to go ahead and put that, as well as I think it's going to last about an hour. So I can add that, and it has the hour and as well as the time I'm going to get there. Also headed to Villanova. I found out where that is now. No restraints there. So I'm going to visit that place. And then I also heard of a school that's kind of in the area, but a little farther out. Apparently, my friend told me about it, called Westchester. So I'm going to add Westchester. And there's something going on there this evening. So I'm going to go ahead and add that, which will last also about an hour. And I add that. So cool. So now I have my list of locations and the times. I may need this later, so I'm going to go ahead and save it and just name it something that makes sense, such as college visits, and go ahead and save it. So next, that's saved. So next stop would just be to just go ahead and click run. And it looks like it's giving me something similar. And yeah, Westchester's pretty far out there, so we'll see if we get there today, but nonetheless, it looks like these locations are also marked like 1 and 2, and if I click on one of them, it actually deletes it and automatically optimizes it. So even though we just removed Temple, it now instantly has us going to Drexel first. But I do think I'm going to get to Temple today, so on the fly, I can go ahead and add Temple, and it immediately updates it. And what's also nice is although we have a list of a couple locations right now, we can add something such as like maybe a food place. I heard like Larry's Steaks is a place in the area, so I'm going to head there. And if I update the route after adding, okay, it doesn't want to add Larry's Steaks. Let's try somewhere else. Let's try cafe. There we go. Good to know. So maybe I'll head there later in the day. And as you can see, it's although I have a list of like 4 or 5 locations, it's actually adding it as my second one because that's the most optimal route. So going to the second one would actually make the most sense. And again, we can see the directions turn by turn. So now at this point, I think I'm ready to keep moving with my college journey.
Hey Ben, so I heard that you were doing a tour of different college campuses, and I also
Yeah.
have Optimap, so I was wondering if I could tag along.
Sure. Yeah. You can friend me if you want. I'm going to go to my profile page. That's my email. You want to write, go ahead and send me a friend request.
Okay, I sent it.
Nice. So I approve that. It looks like you're on my friends list. I actually just saved a college visits route if you want me to share that with you.
Yeah, that'd be great.
All right, cool. So this is a pretty cool page too. It looks like my route was saved successfully and the route's right there. And then it also has recent routes in case I ran one and I want to go back and check it out. It also saves that under the date that it was ran. But like I said, I'm now friends with Alex under here. So I'm going to go ahead and go to the saved routes page and actually share this college visit with Alex. And there he is. And now that I shared it with him, it's under my shared routes. And did you get that on your side?
Yep.
I'll go ahead and let you show what's going on.
Okay.
Get zoom out of the way first.
Yeah. All right. So I don't know if you can see this bulb's in the way, but I see the shared routes in my shared route screen, and I'm gonna go ahead and click load. All right. Okay, route looks good, though I'm gonna be honest. I don't like driving on highways, so I'm gonna go ahead and specify that my settings by going to the profile screen. And then clicking the settings button. And then checking off on avoid highways and then submit. And then I'll go ahead and go back to my shared route. Okay, it looks like the highways are being avoided, which is pretty nice.
But you know what? These college visits might take a while, and not taking the highway is going to take way too long. So I'll just drive and you can turn it back off.
Sounds nice. Go ahead and do that now. Go back to my shared route. And everything looks good, so I'll go ahead and hit start, which will start the live routing in Google Maps. Okay, and as you can see, it does go to only the first stop, but once we're done with this first stop, I'll go ahead and go to Optimap and confirm that it's been finished. So let's say that we finished our tour at Temple, so I'll go ahead and go back to Optimap and then head to the next stop tab and then confirm finish. And this will head back to Google Maps and show the next route to Drexel. So I'll continue doing this until the route is over. So say our tour of Drexel was finished, so I can confirm that. And then go back to Google Maps and it'll take us to Villanova. Same deal here, confirm that. Oh, well, I just confirmed the entire route, okay. yeah, I kind of clicked the button a bit too fast, but say our entire route is finished. And I want to say I want to like walk around Temple's campus. So I can go to the menu and select the transit type as walking. And then say I want to just tour around different buildings, like say I want to go to the Leocore Center. And then maybe I want to go to the Student Center. And then also Charles Library. Okay, looks nice. I don't know if you guys can see, but if I go into satellite view, you can see that it does take into consideration of the paths, so you can walk on the sidewalks, which is good for a college campus. So the route looks good. I'm gonna go ahead and hit start again. And it loads me back into Google Maps. And just like before, it does take me to the first destination. And you can also see that it automatically sets it to walking as the transportation type.
And I think today's going to be a successful day of visiting colleges. Thank you.
So can you speak to some of the challenges of the of building a project like this?
Yeah, some of it was like trying to find things that would make ours unique versus repetitive with other map apps. And the one thing that we really wanted to do that we ended up not doing was actually doing live routing in our app. That was just purely based on the amount of time we had. I think mainly because like you look at apps like DoorDash, they still do it where they bounce you to the Google Maps just because I think that that's like the most accurate. But if we had more time, one of the biggest challenges, like challenge things to do would actually be to do the routing in our own map and maybe even work in like notifications somehow. Yeah.
Anyone have any questions over here?
I have a question. For our capstone, we also did a PWA, and I'm curious, like, like Twitter length explanation, what did you use for your front and back end?
Yeah, I meant to say that in the beginning, actually. We did React.js. We were going to do React Native, but JS ended up working better. And it's also because of like how good it is nowadays, you can write something in React.js and get a very similar or as good app as something in native. So we did React.js and then Firebase as the backend database user authentication. And they pair very well together, which is nice. So yeah. I don't know if that's more than a Twitter length.
No, that was perfect.
It's like the new Twitter.
Right, yeah,
They keep changing the length. Yeah.
Yeah.
I think Tom, you have a question?
Yeah, I think this demo has some new features very interesting, especially the last one, the workflow pass.
Hmm.
And I think as a campus student, I'm more concerned about the workflow pass in also the more safe path.
Mhm.
So
Yeah.
in the future, if you can remind us some paths is the high risk, then we can
Yeah.
avoid this error.
That's a good idea. Yeah.
Where can someone find this app? Because you've demonstrated it. I'm sure it's live somewhere.
Yeah, so it's live on a hosted GitHub with the link that we have. I don't know if we can share that out for everyone to see, but yeah.
Yeah.
Mhm.
I know, are you able to still use it on the website or is it just?
Yeah, you can still use it on desktop. But that's what's nice about the progressive, that when you save it to your home screen, it doesn't have like the URL bar at the bottom or anything, which is cool. So like that's what made it feel like an app. But yeah, you can still do it in desktop view. Yeah. The powers of React.
Yeah. Powers of React. What was some contribution that you made to the app that you were super proud of? And you can all sort of.
Yeah, anyone can.
want to.
I mean, Kenny was working on our newest one was the shared routes. So that part was cool. Ricky did a little about the friending people. I don't know if you guys did.
For friending, it was just trial and error, because every time I started making the new feature after one feature worked, It was just a bug, and I just had to just keep that going. And then like when I finally got everything working, it was just like a relief. Yeah, Firebase has a couple quirks with like user just like making nodes inside of Firebase. So like it creates a new key for each node. So it's a little bit awkward to work with sometimes when you're trying to like share one route with another route, because all gets like messed up somewhere along the way. So you have to fix those.
Would you recommend, future Capstone students to use the technologies that you use to make like a project?
Yeah, I was already a little familiar with React, and I think it was a good decision to go with JS versus native. Mainly because I think JS is easier to learn if you kind of already know JavaScript as well. Native is almost like too picky with like their own tagging system and stuff, where it's like this works for Android, iOS, and desktop, but you have to use this specific one. Versus if you can get it working with JS, then it's like a little smoother. And even if you make it for desktop, we used Endry picked out React Bootstrap, which scaled really nicely mobile versus desktop too. So that's also a good technology. Yeah.
Yeah, coming from a new because this is my first time working with React.js and Firebase, so it was really beginner friendly and pretty easy to pick up once you got going.
Any other questions from the class? Keeping it open, keeping it live. It's a really fun application. I'm happy to see, I know we all were kind of like, what is this app going to be when it grows up? And it clearly grew up because you put so much energy into making it happen. So really great job. Round of applause to
Thank you.
yeah, thank you so much. No, you did an amazing job. And we'll just keep on rolling. Tradester, you got like a minute to to switch with Optimap here, but seriously, great job.
Thank you.
Thank you.
Here, I'm gonna remove that stupid window. It's just been bugging me the entire time.
I'm about to be, I left since it was evening and out the whole way.
It's on Canvas. Let me know when you guys are. No. On Canvas, yeah. Like final demo.
Wait.
Is it always yeah. I would just go to dashboard. That's where I saw it. Yep.
Just making sure.
Okay. Ready? Okay. Hello, everybody. We're the Tradester team. My name is Jafar. I was the Scrum Master for this project and as well as the full stack developer. I'll let everybody introduce themselves.
Hey everyone, I'm John. I was the project manager and I dealt with a lot of the machine learning aspects of this project.
Hello, my name's Sean. I work on the front end and work on documentation.
I'm Nick. I worked on the front end with Sean and Guthrie.
I'm Guthrie. I did a lot of the front end stuff and I also was keeping up with mobile throughout the project as well.
I'm the other Sean, and I did some of the back end API stuff and documentation.
Owen?
Right, that's me. I'm Owen. I mostly worked on the database and getting the machine learning models John made up and running on the GPU server.
I'm Pat. I worked a lot on the back end, setting it up with the tables and all, and I worked on some documentation and testing as well.
All right. So I will introduce our app to everybody. It's a stock trading app, not a stock trading app, but it's like an educational app to teach people who are new to the stock market. I will let Guthrie show you guys a use case.
There's a delay when you share from mobile. So this is our Tradester app in mobile. Let me get that out of the way for you. I should already be logged in. So this is the main page that I focus on as a Tradester user. I'm a pretty in-depth stock trader. I have real portfolios in other companies. I mostly just use Tradester as a quick reference for how my stocks are doing. So for example, I can scroll down, sorry about the Zoom window. I can scroll down and click any stock from the Dow or from the S&P 500. And I get a quick little description of it, and I can kind of move around the chart and see daily highs and lows. And yeah, that's pretty much how I use the app, is just to keep track of those stocks that I already kind of have in the back of my head. And I really love this handle interface. I think it works very well for the purpose that I use it for.
Are we going to talk about that balance?
Oh,
The math.
I just playing with you.
oh, yeah. I said I'm good at it.
Anyways, so is that it?
Yeah, I think that's everything I need to show you guys from this page.
Right. Let me share my screen. All right. So I am a returning user. I've been looking at Tradester for a while, trying to learn more about the stock market, and I'm looking forward to becoming competitive in stock trading. I'm going to go ahead and log into my account and view my portfolio. As you can see here, I have a balance that is not as great as Guthrie's, but I'm doing okay. Here is a list of my stocks. Over here, you'll see a graph of like the last 6 days, including today. And then there's a prediction for the next day. So this prediction is generated by our machine learning model that John worked on mainly. It is predicting for the next close value, which is by the end of the day today. And this is what the close value is projected to be at. So I can also see over here that on this particular stock, I have 2 shares and then I made a profit of 15 cents, which is great. Awesome. And then if I move down, I can see that I'm losing a little bit of money here. And if I keep going down, I made $2.72. Awesome. And this is projected to go up, so I should probably keep it. I have 2 shares of Apple stock that I bought after. I think I didn't buy those, but you know, I say bought, but it's all a simulation. So I got those Friday after market close. So you see here that there's no profit because there was no prediction generated yet, or there's no new data yet. I meant. And if I go down to the last stock, I see here that for this one, I made $1.56, but it is going to go down. So what I'm going to do is sell this and you know, make the profits. Okay, you see here that my balance went up. I can also go to the graph here again. I know Guthrie showed this, but I sort of wanted to talk more about it because over here we have for every stock. Oh, first of all, when I first visit this page, it gives me a random company. So that the reason behind that is to introduce you to different stocks that you might not even be thinking about. If I refresh it again, you'll see that it's a whole different company. So we got Motorola here. And you'll see like a little description about the company. There's a purchase button over here, and it's showing data for like the past, looks like more than a month. I don't know, Nick worked on this. How long is it showing data for?
2 months.
2 months, okay. So if you go down here, it is giving a recommendation. So it's saying this is based on the machine learning model that you guys saw earlier. This is saying that it's going to decrease by 75%, so I might not want to buy this particular stock. if I go to NASDAQ, for example, and for some of these, we have, like for NASDAQ, for example, this is a more accurate prediction versus the one you saw, the 70%. That was too crazy. But it's all fine because machine learning is very hard. And we only had one person working on it. So this is predicted to decrease by 2.18%. And yeah, I'm not going to buy this. Yeah, I think that's about it. I will pass it over to Sean.
Hey, so I'm pretty new to stocks in general, and I would like to learn more about it. And I was thinking maybe you and I could get together and you could show me the ropes a little bit.
Of course, Sean. I would love to do that. Here's the app right in front of you. If you could log in, well, no, you don't have an account, do you?
No, I don't have an account yet. I need to set one up.
Okay. So it does say login, but if you click on login, it'll also allow you to register a new account.
Okay. Well, it looks like your screen is sharing. So let me go ahead and do that. Okay. Cool. So let's see. Oh, I have to do it from register. I see.
I'm not gonna let you show this.
Thank you. Oh, it's too short, huh?
Yeah, I mean, we do have some password checkers. It won't let you do too short or like too common. If you put in password for your password, it won't cut it.
All right, so let's see. Let's continue here. Oh, looks like that worked. Okay. I believe that was the password I just wrote. All right, good. All right, cool. So I'm not sure what I'm looking at here.
So the first thing I would recommend is just look at the stocks page and
Okay.
then sort of look around and
Oh, this one looks good. It's increasing by 37.26%. Can I just go ahead and buy one?
not really, because if,
really?
if you look up here, your balance is 0.
Oh.
You might want to you might want to go to investment and put in value,
Okay.
which I mean you can go in and put in $1 million. It's fine.
Oh, because this is just fake money.
Yes.
All right, so I'll go ahead with 1 million. I think that's 1 million. All right, looks good. Now I can go back to stocks. Would you remember which one that was?
I mean, it doesn't matter. You can buy the whole thing now.
All right. Ooh, these are all looking kind of rough. Oh, how about what if I looked at your portfolio and I could see some of the things you've done?
Oh, sure. Yes, because I am an expert. So
That's great.
going over to social.
All right. And what's your name?
That would be Nemo.
Nemo.
I am very lost. That's
Oh,
not
I
my
see.
password.
Cool. I see you right here. So I can just send this friend request.
Yes.
All right, cool. Oops. All right, so it's sent. Now what?
I mean, yeah, if you change your mind and you don't want to be my friend anymore, you can also revoke it, but
What if
I'd like to be friends.
all right, cool. I can log in.
Oh, you wanna? Okay, sure. Wait, do you want to share the screen?
Oh yeah, good.
I will stop mine. Okay, this,
All right.
stop share. Okay.
Ooh, actually, I don't know if it'll let me.
Why not?
I don't know. It just straight up says that I can't share.
Okay.
So I'm going to accept it from your account real quick, and then you're going to continue to show mine.
Wait a minute. Okay, fine, do it. Just do it.
All right.
I kind of
accepted.
wanted to show everybody how they could go about it, like
Okay.
accepting a friend request. So let me delete you real quick. I'll unfriend you. Sorry, but here, add me again.
Okay.
Wait a minute. Are we not sharing our screen?
we're not
We're not sharing our screen
At
anymore.
all.
Go on Zoom.
All right, there we go. Now we're sharing the screen, right? We're all good?
Yes.
Yeah. Okay.
Yes. Okay. So now Sean is going to add me again. Sorry, guys.
All right, wow. I see you right there. I'm gonna send a friend request. Do you want to log out here and then just go ahead and open up your account real quick?
Yes, because you're having Zoom troubles. Yeah. No, I am lost. Oh, I said my password out loud. Okay, so let's go to social. I'll look at my friend requests. I see a friend request from Sean Man. I am going to accept him. All right, so he's now on my friends list. Okay, so I showed you my whole friends list. That was I didn't expect to do that, but anyways, you now see my list of friends, and I'm also friends with myself. So
That looks
that's kind of
good.
weird.
And me,
Yeah, you can go in and log in.
all right. All right, cool. So now I can go to social and I can see my friend request. You're there. Okay, cool. So now I can just take a look at your portfolio.
Yes.
Oh yeah, looks like you're doing really well.
Huh?
You got some good stock choices. So I'm going to, based on your stocks and also based on the predicted increases, I'm going to go ahead and make some choices. I'm going to buy some AMCR. Oops, AMCR. All right, it's looking to increase. Okay, cool. I can probably afford at least one of those. Stock added, good. And my balance has gone down because I've purchased one, and my portfolio shows that I own one, have a profit of 0 because I haven't done anything yet. All right, wow, cool. Thanks for showing that to me. Of course, of course.
Yeah.
All right. And now,
Yeah,
Yeah.
that marks it for our app demo. Pass it over to John. He'll talk about the machine learning part, which is crazy. Yeah. I will stop my share.
1 second here. Sorry, I'm UI blind. Nope, that's not it. Oh, slideshow. There we go. All right, so here we have, I just have a couple of graphs, but just to start off, the machine learning model we used was an LSTM neural network. So long, short term memory neural network. Basically, what that means is it's a neural network that picks up on historical trends while also picking up on a lot of smaller, more minute changes, which means it's a pretty good fit for predicting stock prices. Now, how the model works is essentially after market close, which is 4:30, we make a call to the GPU server, which then runs the model. And then from that, we get predictions so that we can update the website. Now, to get a little more specific in that model, we are using 2 layers and 32 hidden layers. We came to that by essentially setting each of those values as an iterator, and then running a Monte Carlo simulation, basically saying, look, let's run this 100 times to get the mean, and then graphing the mean. And then after that, picking the top 10 values for each of those, and doing basically getting a histogram. So we can see the mean standard deviation of all of those to try and get the most optimal values. So that's how we arrived at 2 layers and 32 hidden layers. Now, I did train this solely on the SPY index, which is because all of the stocks we are accessing are from the S&P 500. I thought that it would be applicable, that just running it on that would be enough to make predictions on all of the other stocks, which if I were to do this again, I would probably instead run it on each stock individually, just to make sure that we avoid some of the scenarios where we're predicting 60 or 70% increases. The amount of epochs we chose was 150, and that's where these histograms come in. Each of these is a Monte Carlo simulation where we find the mean absolute error and the root mean squared error of our predicted model. Now, this is with a 95.5 train test split because we are making very short-term predictions. We're only predicting a day in advance. And I did also forget to mention that our LSTM model, the parameter we are minimizing is the mean absolute error. So it's a little hard to see. I tried to format those correctly, but even with the same parameters, it just put things wherever. But the change from 50 to 100 epochs, which an epoch is essentially just a run through on the model. Basically, how many times are we going through and training the data? So at 50 epochs, 50 to 100, as we can see, not only do we have less range, which is good. The standard deviation is I believe, a factor of like 10 lower. And the mean is a good amount lower, which means we have less error. And then when we look at the change from 100 to 150, we see significantly diminished returns. But we do also see that our data is no longer left skewed. Sorry, our data is no longer right skewed. And we have a lot more of a bell curve, which means we're getting a lot more of it, which means we can justify using this because the error is a lot better distributed. The reason I didn't run this the same way I did for measuring the other parameters is because we have a limiting factor here, and that's time. And we found that just the more epochs we have, the better it performs. So on the GPU server, 150 epochs takes like 12 to 13 hours. But since market closes at 4:30 and market open is at 9:30 for the S&P 500, for all the stocks in the S&P 500, basically anything within 15 to like 17 hours would be acceptable. And so on the bottom here, you can see what this model looks like on an 80-20 train test split with the validation data on the right. So this is basically predicting as if we're predicting 2 years in advance. As we can see, this model performs exceedingly well on the SPY ticker on very short-term measurements. If I just take a look here, basically within a year, it's extremely accurate. Once we start getting past that, we lose a lot of accuracy. However, as we can see, it still accurately predicts peaks and valleys, which is kind of the biggest strength we have here with the LSTM model. So the conclusion we can draw from this is that if we were using this for just the S&P 500, just for the SPY ticker, this would do exceedingly well at predicting stocks. However, it does not seem that this applies to extending it to everything else in the S&P 500.
Right. And that is it for our day. Any questions?
I can tell you're a stocks expert. Purely based off of that. Yeah, does the audience have any questions? Yeah.
It's like kind of specific, but I was curious how you have the normal line and then the dotted prediction line. What was kind of like the transition from like grabbing the number that you computed overnight and then actually putting that into the graph? Like, was it just a matter of like literally making the graph so it's like the data cuts off at one point and then it's a timeline after that because that hasn't actually happened yet? Or
If I'm understanding the question correctly, so there are 7 values displayed on that graph. We are getting from the back end an array of 7 values. The first 6 are real values, and the last is a prediction. So, and then when we're displaying it on a graph, there's this little setting that you can say that the last n items or whatever are predictions, or like you specify that it has to be a dotted line, and then that's what happens. Yeah. Yeah. Sure, Kat.
John, I think you talk more, because I know you just talked a whole bunch about that, but, so I'm curious, like, did you have background in machine learning before this? And was your original proposal inclusive of a machine learning model? And like, how did that work its way into the application?
Sure. Yeah. I had a little bit of experience with machine learning, mostly just for data science stuff. I had never used a neural network though. In the initial proposal, this was intended to actually be an automated trader. But we had to consider that, first of all, it's not really cool using your own money to do this, but so obviously we had to change things around. And in that, like, we did want to be able to predict future stock prices. And so that's where that came in. That's when I started researching on how to go about that.
Was it a steep learning curve, or was it like you got the hang of it okay?
A bit of a steep learning curve. The biggest issue is that the documentation for a lot of machine learning stuff is extremely poor. So you have to rely a lot on YouTube tutorials.
As far as testing this application works, like how did you know the accuracy of the model like daily? Were you checking, did you, like are the how did you test this?
So I guess I wouldn't know. I didn't work on the model, but what I did, because I only do the fun stuff. So what I did was look at the stocks, and I sort of looked at the ones that were more accurate. And then I kept in my mind, oh, okay, these stocks are accurate, maybe I should highlight them more. And there are a couple that are not, like you saw in the graph when it auto, that we sort of shot ourselves in the foot with that one, with the auto graph. It'll just show you any stock, but it's fine. Yeah. So yeah, I would, and I generally saw that if a stock is accurate, like if today's prediction is accurate for the next day, then it keeps being accurate. So Apple stock has always been accurate. I don't know what the correlation is. Maybe John knows more about that part.
I guess if something is moving in line with the S&P 500, then it works pretty well. I also know that Apple generally trades sideways, which basically means it doesn't go up and down a whole lot. It generally stays at around the same price. So basically it tends to grow as the S&P 500 grows. So stocks like that are going to be predicted a lot better because the model is trained off of the S&P 500 ETF.
Yeah. So it doesn't do as well with like maybe volatile stocks.
Yeah.
It's pretty interesting. Do you think that in a future model, there would be some way of improving it for volatile stocks, or like what would that look like?
Yeah, sure. So first of all, I think having it train like on all 502 stocks would be a much better way of and then just averaging the error from all of those. That would be very difficult to do, but also incorporating more features. So from the feature engineering, all we're using is the close price. Whenever I tried to add more features, such as year, quarter, month, high, low volume, etc., I think tested everywhere from like 10 to 1 feature, and I ranked the feature importance. The issue is whenever we added more features, the accuracy went down, which I thought might have been from overfitting. Now, when I was reading a research paper about it, like far into the project, that said like, oh, we had 56 features for this stock predicting model, whittled it down to 30. So I mean, apparently more features does help out. So that'd definitely be something to look into going forward. But we were also limited by the API we had access to.
And another thing, when you asked about the testing and how we, I thought of something because Nick dropped into Discord like a list of like very accurate one. How did you figure that out? I never.
Yeah, so like when you look at the candle page, it shows you like the percent difference. I basically just had a script on my computer where it would search, it would try to fit stocks either growing or shrinking by about 5%. And we had a pretty decent list of stocks that would change pretty predictably. There's also stocks that are predicted to go up like 100% each day. So Yeah, it was, depending on the volatility, it could change.
Yeah. So for the front end, we used for the React, and then for the back end, we used Django. And then we used an ORM to communicate with the database.
Is the computer that runs the model
No, it's actually Professor Wang's GPU server, I think. And yeah, Professor Applebaum gave us access to it, and that's where we're running our machine learning. Yeah, and Owen probably has more to speak about it because he has it scheduled to run every day. Yeah.
Yeah.
Yeah, I don't think there's much to say
No,
about
yeah, you got
it. I just put him out. I just said everything, and then I pointed it to him.
Would you mind talking a little bit about using Professor Wang's GPU server? Because I know, like, it's a really cool, with the Titan GPU.
Yeah.
What were some of the challenges with using it, or would you recommend future students use it? And if there's something different, let me know.
Yeah, no, it was pretty smooth generally. I mean, whenever we were first starting, we had a few issues figuring out the package manager and everything like that, but no, it was there wasn't, I saw there was some downtime with the CIS Linux server this morning, so that would have been bad if that was, but no, we had pretty consistent access to it. Yeah, honestly, after getting the package manager set up, it was pretty smooth, just like working on your own computers through a tunnel. So that's all there is to it. Yeah. Yeah.
Got a question.
Sure.
On the front end, you have the recommendation that it will go down up like 60%. What is the time horizon? Will that?
Yeah.
Oh, that's for the next day.
Next day down 60%?
Yeah.
Guys, that maybe goes on what Professor Applebaum might ask you anyway, but as far as like advice to other capstone groups, I think this can work its way in there. I've seen some capstone groups where like every member kind of like knows what's going on in every part of the project, but it seems like you guys had pretty like set goals for what you were doing in the project. And I'm just curious if you can speak on that. Like, would you recommend that? Did you like that aspect of it? And did it present any challenges in like communication or development?
Question.
Yeah, that's a very good one. I got to think about it. So, in terms of things that were oblivious to me in the project was the machine learning thing, and then how it's being automated in the back end, like how it's being automated and called every day. That's about it. I'm fine with that. Like having someone doing something that I don't know about as long as I can trust them. Yeah. To deliver. So it's cool. But I also like to have an idea of what's going on. Just because if I need to make a change somewhere, it's less of a hassle. Since I already know what's going on. I don't know if anyone else can speak to.
I think I can add on to that.
Yeah.
So I worked primarily on the back end. So for a lot of these demos, all the features, pretty much everything you see that we're going to present to you is on the front end, right? So I have nothing to really do with that, except they're pulling the data from the back end. But one of the things that we were talking about a couple classes ago was that we didn't have any like big bad merging problems on GitHub. We were all saying that in the past, when we worked on big projects like this, we ran into huge problems merging all the stuff together. I think the fact that we kept everything split up and everyone was just doing like one thing made it so that, okay, it's time to put the puzzle pieces together. There's only a few things you have to work out. People on the front end just need to know what they're getting back from an API call or something like that. So I would definitely suggest having an approach like this. You're not as involved in everything, but I think it's for the best, really.
Nice. Round of applause for not having heard. That's kind of like momentous, right?
A few.
Yeah. I've heard some horror stories this semester more.
Okay.
But
I always dread them, and then it turns out to be one line. I'm like, cool.
yeah. It's like, oh, header change. Okay. Yeah. So as far as everyone has asked really great questions, so that stumped me for asking any other questions. So no. Would you recommend students do a machine learning project in the future? Is that something that is like feasible for this class? It's always a really great question. Given your experience, what would you say?
Yeah,
Tackle
I definitely recommend it. It's, I feel like going forward, anyone in comp sci is gonna need to know how to do at least a little bit of machine learning. I will say, the barrier to entry, especially if you haven't taken like a formal like machine learning class, is pretty rough. But it's still doable. There's a lot of good YouTube tutorials, and yeah, that's probably where like the shift is gonna go in the following years. So it's definitely a valuable experience to have.
If I could add on real quick, I know what John did was really complicated with machine learning. But something I added over the weekend is actually just the descriptions for every stock. They're just all machine generated. So, you can do either really complicated stuff or you can make it pretty simple.
Well, honestly, I don't have any more questions. You have a question?
Okay, the only thing that came up with the bit sheet was the friend portion of this. So, you know, I'm thinking this is a great way to lose friends and gain. But I guess my real thought was was this considered more of a gamification of it, where you're seeing other people's and you're sort of hitting yourself against them with that kind of thing that's going on there?
More of a mentorship, like, but also, yeah. Oh, thank you.
I don't do stock tips. I won't give any of my stocks away. Yeah, so it's an interesting thing. Yeah, like what was part of the inspiration of that feature? Because I know we talked about it in another demo, but it's still like pertinent information. Like, why a friend feature?
So there's two ideas. One is just teaching your friends, like sort of how, if you're interested and you have a friend who wants to learn but they don't know, you can show them what a good portfolio looks like.
Yeah.
And then there's the other one that Sean thought about, like I think it was Sean. The one with maybe starting off with the same investment value and seeing what each person can do. Yeah.
Yeah.
I don't know whose idea that was. Maybe
Gamification.
Were there any other apps in your research that like had this feature as well, or is it more of a unique to Tradester?
I don't remember what exactly it is, but there is some stock trading platform that like paid a lot of influencers to advertise, and one of their selling points was you can see what your favorite influencer is investing in if you like add them as a friend. I think that's like what I brought up when we had that meeting. So that's kind of where we got the inspiration from it.
Well, I think with that, we'll move to our next project, but it's been amazing. Great job.
Thanks. Thank you.
You got Zuckerberg.
Pretty. Camera.
Okay, I guess we're all.
Move it over. Was there any,
I haven't been paying attention, but no, good.
No
chats. Yeah.
My neighbors.
All right, we all good?
Looks like it.
Sounds good. So, hi, everyone. My name's Ethan. I was the project manager for our project, which was TuTraffic.
My name is Isaac. I was the Scrum Master for our project.
My name is McGuire. I work on the front end and a little bit of the database.
My name is Logan. I did some with the machine learning and a lot of documentation.
My name is Brian. I did a bit of the front end for mobile and desktop.
My name's Adam. I work on integration testing and DevOps.
My name is Raymond. I work on the front end and the database connection.
And my name is Jason, and I also worked on the front end. Sweet. So TuTraffic is a application that aims to make parking for Temple students and people who live around Temple easier. And the way we do this is with our Raspberry Pi setup. They each have a camera, and they would be set up over a parking lot. Typically, we would, aim it outside a real parking lot, but we don't have 10 cars to play with. So we made a little model to show what it would work like. It does this, detects all the available spots and then sends it off to our front end app. Let's get started with the demo.
All right, so I am currently circling the Circ building because I have a class to get to. And since I am nearby, let me use the current location. And look at that, a bunch of parking that's near me. So I'll have an easy time finding spots, and also I didn't have to type in my address, so no texting and driving. The meter icons are for street parking, and the little car icons are for lot or garage parking. Now I cannot parallel park, so I will be switching it to just lot parking. I'll go to my user profile and select lot or garage. Then I'm going to go back to the map. And now there's no street parking. It's only lot parking. And I'm going to click on this one right here. Look at that, Circlock. It has 8 spots. Great. And I'm going to navigate to that. And if I was actually going, I could just, it takes me to Google Maps and I could just click start. Automatically go. Oops. All right, and now I have a lot of classes in Circ, so I'm going to favorite this spot, click on browse, click add to favorites, success. Check my favorites, and there it is. And I can use this whenever I want to. It's automatically saved, and quick and easy if I want to check the status or directions. After class, my friend is going to come over to my place at the View, and they're worried about parking. So I told them about TuTraffic. Let's see how they're doing.
All right, so I'm going to visit my friend in Philly later. I'm a bit nervous because I heard Philly drivers can be a little aggressive, so she recommended me TuTraffic. So I'm gonna type in her address in the search bar. So 1110 West Montgomery. Search. All right, great. There looks like there's some spots around. I'm trying to save some money because I might be here for a few hours, so I want to not have to pay per hour. So I'm gonna go to user profile, and I'm gonna make sure I'm selected only free parking. So let's go back to the map, and all these spots should be free. All right, this one looks good. Let's click. So this is on Warnock Street, and that is currently being represented by our display over here. So all the data that I'm getting on my screen is from this thing. So I'm gonna get ready and I'm gonna let this sit because it live updates. So hopefully when it's time to go, there'll still be enough spots so I can come here. Oh, and look at that, I just got a notification on the bottom right that said there are less than 5 spots available. And I have a little bit of a commute to Philly, so I don't think these spots are going to be here when I get there. So I'm just going to pick a spot with a little more and navigate there, and then I should be all good. So this app is really helpful. I wonder how they set it up to get it all working.
Okay, so I am an IT person working for Temple who has set up this system on our lots. We have the camera aimed at the parking lot we want to work on it, so now I can run our little setup program to get it started. So it will display an image of the parking lot to ensure that you're facing the right way. So I can go here and verify that this is the image, and then I can now crop and select only the parts of the parking lot that we want to be looking at for detection. And then now it asks me if it's a lot or street. I can lot. It'll ask us for the name. This is Dirk. And then how many spaces we think we can fit. Just for demonstrations, I will say 10. And now it will start capturing a set of 30 images. That way we can average them out to remove any moving cars, so they're not counted in our parking lot spaces. Once it averages out the 30 images, it will then run our open source image detection called YOLO through OpenCV. There we go. It says there are 9 spots available. And if we go onto our website, you see the search now has 9 spots. So it is sending that information to Firebase, and then our website is updating with that information live.
So this was our demo for TuTraffic. We saw that our application works on the cross target and we like favorite spot, and we also saw how the backends work and how it will detect moving cars and with people taking up spots. If you want to try the application, it's currently up right now, and if you're here in person, you can probably move the cars around to see what's happening. Thank you all for coming.
Are there any questions so far? Anybody want to play with the cars? Anyone want to see what I want to do? Deliberately just at the end to play with the car. The only, yeah.
How hard was, I don't know who worked on the image detection stuff, but how hard was it? And what were the challenges that came with it?
So we essentially had 2 different setups. We had our free parking and we had a lot parking. The machine learning algorithm we use was essentially stock. If you look up YOLO V3, it is an object detection, and it will detect tons of different things. We had issues with it detecting our miniature streets as like handbags. So, you know, it detected a bunch of different things, but we just narrowed it down to like cars and traffic buses. And so that in and of itself was like pretty plug and play. The initial setup was a little weird. We hadn't had very much experience with machine learning before. And when it came to the parking lots, it really wasn't too difficult to get it up and running because the user themselves could set what the maximum amount of spots was. So you take your picture of your parking lot, you can say like, oh, the maximum amount that it fit in here would be 40. So then it detects 30 cars and it outputs that there's 10 cars on it. That was quite easy. When it came to the street parking, Isaac was doing that. It was a lot more difficult because there's no reference frame we could rely on. You know, we don't know how far away the camera is going to be. We don't know how big the cars are relative to the camera. So we can't kind of decide how big a spot is from that. If my understanding is correct, essentially how it was working was we would take one of the cars that we did detect in the image and then just like move it over and find a new spot and move it over, find a new spot. Any spot that was filled up would be detected. Not sure if that's exactly right.
Yeah, pretty much. It's slightly changed for the end where it was basically, it would take the information of the cars on the screen and would use that to kind of get an idea of how many spots could be in that area of the street, and then would take that average car dimension and roll it across the screen. And if that bounding box corresponded with the bounding box for a car over a certain interval, I think it was like 90%, then we would consider that spot taken. And if there
weren't spots, or if there was no detection, it would consider that a free available lane.
Yeah, so did our best with this, it's certainly not perfect. Neither was this. Especially with the toy cars, we noticed like with the stock images that we were getting and like doing our initial testing with, it was working really well at detecting cars. Then we take it out to the real world, like pointing it outside the window, there's a tree in the way. The lighting isn't the same all the time, so we were having difficulties with this, and the model isn't obviously trained on toy cars, it's trained on real cars. So we had some issues with that, but the machine learning really wasn't too bad. Because it would take, I feel like it would be a lot harder to make it equally better, you know, like the next step up would be a lot harder, but it wasn't too bad for this.
What was the final delay time of, between over here recognizing the cars and updating the server?
Yeah, so I think with it running on the pies, it was about 9 to 12 seconds for each detection, depending on the size of the image, which is a lot of why we let you drop it down with what important information is. When it was running on our computer, like I know on my laptop, it would take like 2 seconds to run. So it's not that heavy of an algorithm. And our initial idea was that we wouldn't have to have this like a backend server running, but if we were to do it again, I think that would be a better option to send the pictures off and have it run on a better computer than on the rinky dink little Raspberry Pi. But it's not too slow. Our interval of updating would be about every 20 seconds. So as long as it was below that, we're
something you said earlier has to do with the question I had, which is like, how realistic would it be to implement something like this on Temple's campus? Like, do you think you'd have to put like a lot more work into it to get it production ready in that way? I know you're mentioning it, like issues like lighting and trees and real people using it would kind of mess up. Like, did you have an idea of where it could go from here so that it could be implemented like that, or can you speak on that?
Yeah, I think that it would take a lot of work to get it like production ready for that. It's like pretty good, but I don't think we could really be prepared for all the edge cases that we've come up with. So like, what if there's traffic and like all the cars are stopped in the middle of the road? Like right now, we average out all the pictures, so any car that's consistently moving isn't going to get picked up by the algorithm. But if we if people were just stopped in the middle of the road, like they tend to do in Philly, then we have trouble with that. So I think it would take a lot of work to could do it, but it would definitely be at least another downhill process.
What were your favorite parts of the project? I like what. This is gonna be like a Blair Witch project at the end, but like, what was your favorite contribution to the project or favorite thing that you did?
Personally, I really just loved, like, I never really worked with machine learning before. I tried a couple of times, like nothing was working. And for this project, with the help of Isaac and Loaded specifically, it was just like we managed to get it working within like a week. It's like, oh wow, this like that was so nice. It was the rest of it that was hard. But that was what I enjoyed the most.
I guess it's the same for me. I think Isaac will probably say the same. They were more in depth with it than I was, but I don't know, machine learning is such a hot topic right now. So there were a lot more resources than I thought there would be. So it was really nice to learn something new and relevant.
Put it on the list.
Yes.
Saw there was, I stomped over questions from here.
Yeah,
It's all sunlight.
Yeah. You're talking about like the billing things, reminding me like, I feel like people use like traffic cones, like trash cans to save on a parking spot. Is that something you could detect?
Well, the YOLO algorithm is technically like an object detector, so we could spend more time and like incorporate those. Essentially, it would just be like, it would be more difficult with the parking lot, I think, for that, but with street, you could just have it count like any object intersects in the way as part of that. So if it's blocked by any object, it would be available, but then you would get issues with just like all the rain traffic in the street.
I have a weird one, and again, probably another Capstone project, but, it occurs to me, you were talking about the street parking, where the camera, obviously, there's an angle of attack with the camera, where the further away, the harder it's going to be to determine what the size of the space is available.
Yeah.
And what jumped into my head instantaneously was, what about overhead drones?
Is that we were getting like the best results on in our initial testing, where there's like nice overhead shots, and also the very clear like side shots, anything from like same level. I mean, obviously you can't see the bar.
Right.
So that would be nice, like maybe we can implement that, like having it on site goals facing exactly down. We also use a lot of the range.
I was just thinking of the practicality. Initially, I have to say, when I first heard this project, I was like, why? Now I see the project and I'm going like, I want this now.
Yeah.
And I think there's like a serious need for this, and then that's what got me thinking of the drone idea, where you could set it up so that the drones fly, there's like, let's just say it's simple.
Yeah.
And like the campus would be quite willing to pay for that, for it, you know, yes, I'm a bit business oriented. But let's just say then they absorb the cost and they get the approval to fly drones, but there's a whole issue. Let's just say we can make that happen. Would it be possible within the context of the model to be able to determine, based on your fly time, the number of drones that you have, and be able to track that, be able to organize and know where those spaces are? Less of an issue with the parking lot, obviously, than free parking, it would be more ideal, and you would lose the issue of having to negotiate for space on a light pole or a breakfast. I don't know, it just struck me that when I saw this and I saw that actually work, that there's a real possibility there, I think.
Yeah.
But I don't know, but you know, my experience with them, obviously, what you guys did is like, that's so good.
I think that is a really interesting idea. It would be good for street parking, especially if you could like line all the images to one really long image.
Like, the issue of trees and over coverage and things like that.
Liability issues.
Let's say, I think there are two people have to die from like.
Several car crashes.
It's funny that you did mention drones for doing this. When I was first researching how to do this kind of lot and street detection, one of the papers I found was doing overhead parking lot detection with drones.
It's happening.
It's funny, it didn't even occur to me, drones, so I don't know what I'm like.
Well, I don't know what the work on that is. Somebody else already thought of it.
No,
I'm still behind.
Yeah, yeah. I feel like we got Ethan's perspective on like favorite parts of the project. How about the rest of the group? What were your favorite things of working on this? What would you recommend to work with in the future?
Well, I did a lot of stuff with user settings, so having it be that they can change from street to lot and stuff like that. And it was just really fun when everything was working, when things would work from both the machine learning end, so like we would actually know how many spots were there, but also when I would have it be street and it actually would only show street parking.
Yeah, working on the testing, I wasn't sure if everything was gonna work together, so it's a nice surprise to me that like the test would pass, and it was mostly errors with my test logic rather than the project itself. Like all the tests were passing, which is
Glad to hear this testing. That's good. Okay. Yeah, yeah. Yeah, oh, Jay, yeah.
For the like YOLO algorithm for the object detection, is that the first like, have you guys explore other like algorithms? Joining that one? I just did the research on that.
There were a couple other options that were kind of more complicated, and you would have to, they weren't trained, you'd have to go in and train them with your own images. And we found that just using a pre-trained car detection image model worked way faster.
Really don't have all those.
I was curious, who worked on the Raspberry Pi piece of the project, and can you speak on that a bit? I'm curious, I've never used it before, and I know like we're talking about brainstorming capstone projects in the beginning of the year and like looking at that. I know you were saying like, oh, probably use a better like back-end server and everything, but can you speak on your experience working with Raspberry Pi?
It was me and Isaac working together on that mainly. We each had one of us home working on it. For me, to be honest, I found it there's like so many little things. I could not get the camera working for the good majority of the semester for reasons that are still unknown to me. I feel like Isaac had a bit of a different experience.
I too found it pretty annoying. There were a lot of like small weird things you have to tweak to get it to work properly. And then also the fact that since it's the Raspberry Pi, it's just a lot slower. So you'll develop the code on your main computer and then it'll be instant. And then you go over to the Raspberry Pi and you have to wait and you're still waiting. And oh, now you see it's wrong. And then you have to go back and start changing it. Some of the other issues we kind of had with the Pis were the cameras they're depreciated now. They don't technically have support anymore. They have legacy support. So trying to get those to work was a real hassle. But I think overall, using a Raspberry Pi to kind of enhance your project is a really fun way to do it. And you can do a lot of, I just wouldn't recommend doing a car detection.
You have a lot of control of the environment, like going from trying to detect and the actual outdoors to like having this that we play with a lot, and we can actually control it, the lighting, because it would work great in here, and we pointed out the window and the image is pure white. We have no control over the exposure or any of the actual camera settings on it. It's just like take an image. That wasn't great, but they're really fun to work with. Because it's just like a smaller computer, but
Would you recommend it as a capstone project, or is it kind of like the same, just like, yeah, like as a supplement, but don't base the project around it?
I think it's good as a embedded programming project. So it's like if that's something you're trying to get into, like obviously it's a great experience because it's like the Pis are, while they're like a little finicky, they're also incredibly user friendly for one of these types of computers. So it's like a great intro to that. I would recommend it for a captain probably.
Yeah, I was gonna ask, so because it sounds like most of it is, like most of the frustration is hinged on software. So how much Linux experience do you think a student that would take on a project like this needs? I feel like I know the answer, but yeah.
It's like a mini Linux that you get with it. So I wouldn't start this project if you had to be like, how do I make a directory? How do I ski into a new direction? Like that probably should be your first thing that you have to learn if you're trying to use these. It should. I would say come in with some base knowledge, but if you're doing it at Temple, you get that.
Yeah.
So you mentioned that you guys both have the Raspberry Pi. Do you have like any parking lots in your room?
This was pretty recent. Up until then, we had just we're playing it outside of our house. Hang on. But this was just to get some extra control that was better.
I not really go on a tangent, but I heard about you guys were interested in machine learning and it should be part of the project and so on and so forth. We do offer machine learning 4,000 level courses, but in the past semester, the enrollment has been low relatively than what's the
Yeah, I know I applied for machine learning class last semester and it required Cal 3, which most people don't take.
Oh, that's true.
On my end, I was coming out of the double page with 5 outside. I just did not have the room credits wise.
Oh, that was me too. I'm CS math. I just had no room. I wanted to take it so bad. I just couldn't.
No room means cannot be the schedule.
I actually, for me, it wasn't necessarily a credit issue. It was like a scheduling issue because I was in both departments and like everything that was required just like overlapped. I didn't have room for extra electives.
I was trying to, I remember I was thinking about this like 3 semesters ago, and then I was just doing it in my head. I'm like, oh, I have to take Calc 3, and I'm trying to get this in with all the rest of my stuff, and I was like, I need to graduate first. That's first priority.
So if we can relax the Calc 3 requirement, that will help.
Yeah.
Yeah. There's not many other classes that you need Calc 3 for, in the CS like track, at least that I know of. Like there's like 2 or 3 other ones. So if you're, because like machine learning is so popular, and it's like something industry to get into now, that would be great. So like, or if there was the Calc 3 class version, the version I didn't need it.
I took machine learning last semester, and I would argue that I use probability statistics and concepts from calculus 2, and a little bit in calculus 3 at the very beginning, like doubling that was about. But I saw that probably. Okay, all right.
You got your answer. Oh, hey, well, since we're running out of time and I want to give, well, actually, we've run out of time. But I want to give you time to like mingle and just take in that the semester is over. And it's been an amazing one. It's been a beautiful while.
We should give a thought to here. Be taken up.
Well, again, feel free to mingle while I set up for section 3, but it's been amazing. Really, yeah.
That's why I'm like, bro. Like,
Well, it would be myself. Oh, no.
Yeah.
It's my first one. Nobody. Thank you for yeah, next semester.
We're doing our own thing.
Yeah.
Yeah.
Starting funny.
Yeah.
I mean, really is like, you don't want to go someplace how like. Control.
Not like they're supposed to like inactivate their courses, they don't because like, Ian wanted us to have.
Yeah, I've seen them once.
Yeah, there hasn't shown. Well, it's the number one. And then I found that like, I didn't like an home too. Just go out and then we like access it or No, we presented Thursday. My best friend.
Yeah. Yeah.
But I will.
Yeah, thank you. Let me know if we have yeah. And yeah. All right. You're
Or like.
Right.